Thanks everybody for coming. Good morning for the last day at Eclipse Con. Here I'd like to talk about Piranha Cloud and Eclipse GlassFish and how they are related. Eclipse GlassFish, you can guess from the name, is an Eclipse project. Piranha is not yet in Eclipse, but eventually, hopefully, it will join the Eclipse Foundation as another open source project. So I'd like to introduce it before. Quickly about me, for those who weren't in my talk yesterday, I'm a Java champion, Czech Java user group lead, a committer on several Jakarta EE specifications, and also a director at a small company so far, Omnifish, which provides GlassFish server support, and also in case you want to use Piranha Cloud, which I will introduce, we provide support for that too. So let's start with application servers first. So I'd like to show you how the Java ecosystem evolved from application servers. And I'll use the GlassFish and Piranha as an example. Application servers were designed to be reliable, secure. So this is not only like the dogma, but it's true. They were designed to provide high level of quality in production, a lot of features so that you can manage things in production. And they were also designed to save some resources in the past when the resources were scarce. So you could deploy multiple applications on the same JVM and manage them together. But because of this, they were actually slow to start, because they had to prepare all of this so that to be able to serve during runtime without any restarts, to be able to be managed runtime. And there was no need to really be fast, because at that time computers were slow anyway. And even now, it's sometimes not necessary to start things really fast. It's enough to start them fast enough. But when you run the application all the time, you basically need to support that time when it's running, and startup time is not so important. But there are situations where you really need your applications to start fast, especially when you quickly start them and then stop them, start them, or scale them as you need. And the question is if Jakarta EE itself, as a standard, or its implementation based on Jakarta EE, can be any close to just plain Java start times. And I will also show you that plain Java start times are very fast compared to what many people think. And I also thought like that 2 years ago, that the plain JVM needs some time to start before it can serve the application. But that's actually not true, or not entirely true. So a few words about GlassFish. For those who don't know, it's an open source project. It's a full Jakarta EE full profile compatible application server. And as I said, as many other application servers, it's robust, provides a lot of features out of the box, provides easy management. Well, what is more interesting is the current status. So if you don't follow what's happening with GlassFish, it's no longer just a reference implementation, which it used to be when Oracle basically stopped supporting it. So GlassFish was a project that was there just to certify that Jakarta EE can be released and can be implemented. But now it's supported by multiple companies. There's an active team behind it. And it was the first runtime to pass the Jakarta EE 10 TCK, so it was the first certified Jakarta EE 10 runtime. It runs on Java 11 to Java 19, so the source code was uplifted to run on any Java version, and it's kept that way. There are tests for any new Java version to verify that GlassFish works even on the like pre-builds or early access builds of the next Java version. And then there are some new features on top of Jakarta EE 10, like microprofile config, MVC. Then there is embedded GlassFish, which is like a GlassFish server that you can start from within your application and manage from within your application. You don't have to install it to be able to run your applications. And then there were a lot of fixes and new tests written by the new active team that is behind GlassFish. And now we're coming to Piranha Cloud. What it is. Piranha Cloud is a new framework. The cloud name doesn't mean it's a service in the cloud. So I realized that it might be confusing because yesterday or two days ago there was another talk about Piranha Cloud, which is a cloud service. This is just to give you the meaning that it's suitable for cloud development, because in the cloud you really often need things to be lightweight, start fast, so that you can shut them down any time and then start them again without too much delays. But what is the relationship with GlassFish? Its relationship is, first, is part of some people working on GlassFish also work on Piranha Cloud, the new framework, but it's also based on components that are used by GlassFish, which are like Jersey, Eclipse Weld, quite widely used components. But it also builds on several components extracted from GlassFish to a separate project or library, which is all these. So in the past year, a lot of functionality was extracted from GlassFish so that it can be reused in other frameworks. And Piranha Cloud is one of the frameworks, probably the only one right now, besides GlassFish, that uses them. But the idea is to be able to reuse the code from GlassFish without actually depending on GlassFish. And what is actually interesting about Piranha Cloud is that it's no longer an application server by itself. So it's not designed to be reliable and secure and manageable for the whole lifetime of the application. It's designed more on speed and get you up quickly and running for easy development. But it still provides a reasonable subset of Jakarta EE. So if you have an application that you would deploy to application server, there is a small chance that you will be able to run it on Piranha Cloud. And as Piranha Cloud matures, it's more and more support for Jakarta EE specifications, and eventually the aim is to support Jakarta EE web profile. But the core at the Piranha Cloud is a bare bones servlet container which was designed and written from scratch. So that's why the core is very fast, because it was the servlet container was redesigned with plain Java, no class path modifications, no magics there. With focus on basically just Java programming, Java language, so it's configurable from Java API. You don't use, if you don't want any WebXML or any textual configuration, there are extensions which you can load to read configuration from WebXML if you want, but most of the time it's designed to really assemble everything in Java using a reasonable API. And it's still a servlet container, so you can deploy any servlet on it. So that's the idea, to build on a really fast, composable runtime, and you can then reuse whatever you have. If you created your own servlet, you can deploy it there. If there is a servlet, like Jersey basically is integrated as a servlet with some extra integration points. So if there is existing servlet out there, you can already deploy it on Piranha Cloud, and you have the solid base to get a fast runtime. So there are several Piranha Cloud extensions to the core engine and to the servlet. So besides deploying servlets on the servlet container, you can add extensions which know more about the runtime, so you can hook into the runtime. You can provide your own annotation scanning mechanism. There is a default one if you want to use it, which basically caches annotations, caches reflection and other Piranha Cloud components. If they detect that there is this annotation extension, it will use this extension instead of going to the Java reflection. So it can be faster when the same calls are cached. And you can also use the annotation information or read the annotation information from somewhere else. So that's the idea. If you have these extensions, you can modify what the engine, what the other components use, how they work, and you can tune them to be really fast. You can build your own extensions if you want to really improve some particular area. There's also support for Hazelcast to store HTTP session in the Hazelcast, so there is already an extension for that. So that's an example of an extension that provides something else than Jakarta EE API and something else than Jakarta EE functionality. But it integrates into Jakarta EE because it extends the HTTP session mechanism to make it scalable to multiple instances. And then Piranha Cloud can be embedded, so you can run it from your code, but you can also run it the other way around. You can take one of the package distributions which already provides some subset of Jakarta EE, some extensions, in a coherent way, and create a web application and run the web application together with this runtime on command line. So you can build a standard web WAR file and then launch it from command line using one of these distributions, depending on what the WAR needs. If it needs just Jakarta EE core profile, it can use core profile. If it needs more, web profile is not full Jakarta EE web profile, but it contains some more things, and eventually it will become certified as a Jakarta EE web profile. There's, for example, JSF, Eclipse link, transactions, and things like that. So it's quite close to being web profile. Okay, so I'm not going to just show slides. I wanted to show you some code and just something to think about. And first, I'd like to compare the speed of the server. So just just something that might be interesting is to show how GlassFish 7 starts with a simple application and how long it takes until it's ready to serve the first request. So the source code of the application is really simple. It's a simple servlet that just responds with hello world, hello from GlassFish. And I will first show, not this one, first show what the application does. But you can imagine that when you access the URL, you will basically see the message in the browser. Yeah, so this is the application. Nothing fancy, really simplistic application. But the thing is to demonstrate how much time different runtimes need to just serve this simple, the most simple application based on Jakarta EE APIs. And you probably saw that it takes some time for GlassFish to start, but let's measure that. I have a script to measure the time from the start to actually serve the first request. Not only the time that GlassFish reports it took time to start, because there's some JVM initialization before GlassFish can even start measuring, and then something happens when you issue a first request. So I want to know when the application is basically ready to serve the first request. So let's measure it. And the measurement says 4.1 seconds. So let's store this measurement here in this chart just for future to compare. I'll come back to that later. Just for those who are interested to know how Java itself is so fast, without any application server, without anything, I have a very small application, a very simple application that just prints hello world, no HTTP, nothing, just the most bare bone we can get with Java. So this is the code, even less fancy. Everybody knows that. People who start with Java hate all of this, public static void main, but I hope you're not like them. So let's just measure that. And this measurement doesn't start the server, it just starts the application. The application finishes and it measures how much time it takes for the application actually to run. Okay, almost instantaneous. The application finished in 60 milliseconds. You see the difference? There is this thing in the second column. It's almost invisible. So the question is whether we can get to this this fast with some framework, like Piranha Cloud, or yesterday I showed Quarkus, or we are forced basically to use plain Java and really think about what we add to this to really get small startup times. And where it matters is serverless. It also matters in Kubernetes and microservices when you want to scale to multiple instances, but there you can basically handle with a couple of seconds of delay because you have other services already running on serving requests, so it's not that problem. But in serverless, you can get to the point where none of your instances are running because they are shut down automatically by AWS Lambda or whatever serverless functions service you use. And then you have this problem with cold started because everything has to be started, and when things scale up, everything has to be started. Again, for any new request. When you have Kubernetes, each service can serve multiple requests. There's parallelism, there's multiple threads. But AWS Lambda, for every new request, every new event, you need to start the process, the JVM itself, if it's not already available and cached somewhere. So let's now see what Piranha can do. With Piranha, you can do the same as we did with GlassFish. You can deploy the same servlet, Piranha app. So the same servlet is very similar. It just prints a different message. But here, I'm starting Piranha in embedded mode, so you can see the code that actually starts Piranha. It's also possible to run the same application as we ran with GlassFish if I use the pre-built package of Piranha and started the WAR file. But I want to show you something different, something that is more flexible. And with Piranha, you have two ways of running it, basically. One is with HTTP. So if you really need to serve HTTP requests to simulate what basically GlassFish does or other frameworks does, or not simulate, to do what they do. But Piranha does it in two stages. You first initialize the container itself. That's the simple object, and then you bind it to an HTTP listener, which can be anything. You can implement your own based on Tomcat Jetty if you really want. But there are, I think, 4 already built in, and there's this default HTTP server that just delegates all the HTTP requests to Piranha. It will create the HTTP request object and delegate to Piranha. So in this case, we have basically the same that we did with GlassFish. So we can measure the same thing. Here we're mapping the servlet with the API, no web XML, but it resembles what is in the web XML. So if you have servlet mapped, basically you need class of the servlet and then the mapping. In this case, in web XML you would have to have 2 definitions, one for servlet and one for mapping. It's also possible with Piranha, but there is convenient methods to do that together. And then you start first Piranha, then there is a web application processor that basically connects the server with the engine, and then you start the server you want. And that's it. So if we measure this, we can see whether we can get faster to the plain Java and how fast it is. Piranha up. So, well, again, measure the same thing. Wow. Oh, there's a different read. I think I modified a different file yesterday. Okay, so once again. Yes. So you see there is a response, and actually, well, no, I think I have something running in the background because it gives me a response from GlassFish. Yes, sorry for that. So now we get a response from Piranha Cloud, and it actually really started in 237 milliseconds and served the first request from the servlet. So let's try to compare this with Piranha Cloud. This is what we get. And I don't know, what do you think? Is it fast enough? I think so. It gets way under 1 second. It's very close to the plain Java style. You could argue that, yeah, Java is still like 10 times faster, but only when you really compare the times.
But you haven't done anything in Java, so you still having HTTP server.
Yes, but it's initializes the whole engine. It initializes a servlet container. Yes, but when you do some of your own code, when you put it on top of plain Java, it's the same thing as you would put it on top. So if you need to process a request, then adds up. But this is just a base. This is.
I guess that's our point. In your plain Java example, you haven't done anything except for printing to the
Yes.
You haven't gone to a socket.
Yeah. So it's almost impossible to get to that level because it does nothing. But
Actually, my question is, in Piranha Cloud, can you select the features or profile you want to? You said that you remove basically what is useless for you. Is what you said on your slide. In the previous slide, you said remove useless thing. Yeah.
Here?
Remove
yeah.
Okay, but is it not better to actually do the opposite? Add what you really need?
Yes, what Piranha Cloud does, it starts from very small thing and you add things on top of it. This is just a general thing. If you
sorry, in your code, you already have an HTTP server by default.
Yes.
So if you, for instance, I just want to do some JPA stuff,
Mm-hmm.
no HTTP stuff, only JPA
Mm-hmm.
directly in my code, then I still have the HTTP server.
Yes, but I can show you.
even if I don't start it, it's there.
But
In terms of size of
it's just a dependent. Yeah, I will show you. I will show you. So there's another way how to start Piranha embedded. And there we have a minimal app, which basically just starts the engine. No HTTP server there. You can create a request on your own. There is a builder to build the request object, so you can assemble that by yourself, service the request, you get a response, again an object that you can then do anything you want with. And in this case, I just take the response body as a string and print it out. So this is even closer to our base Java application. It just uses servlets to print the string. And in this case, we're still not there yet. But where do I have this? I haven't. We can measure if this helps and how. So with this, we get to 150 milliseconds. If we strip, I don't have, okay, I'll create it here. Plain Piranha. So we can get even faster if we don't need this HTTP stack. The truth is, this application doesn't do much, so it's only servlet, and nowadays most applications are not based on servlet, they are based on some other things, like they need dependency injection, they need REST. So the truth is, Piranha Cloud doesn't optimize these, so it just builds on Jersey and Weld. And if you want to integrate, I have an example here, we still have some time. If you want to integrate that, that's quite easy. And I have an example, so we can compare, again, how fast it is in more realistic scenario when you need to build a REST application. Where do I have it? Here. So the code is a bit more complicated, but not that much. We have a Piranha REST application, but in this case, it builds on core profile extension. So I don't only load Jersey, but I load some other things that are in the core profile. I think it's not the full core profile yet, but it's building for. I'm not sure if everything from Jakarta EE core profile is already there, but there's Jersey, there's CDI, so we can edit there. And then I also edit annotation scan extension because Jersey needs annotations, so we add the extension to make Jersey run a bit faster. And then there is an example of my own extension, which basically discovers the annotated classes and makes them available for Jersey. So it provides information for the scan extension. Because everything is on flat class path, the classes can be anywhere, and the extension, these annotations scan extension, doesn't know all the places from the class path, so it can't scan everything. There is a trick which, for example, Weld uses. It somehow loads a class, then it detects where it's on the file system, and then it tries to find all the other classes on the file system, but it doesn't work if you have, like, in theory, something loaded from a network, or you use a different class loader. You can package everything in a custom class loader, which implements some interface, and then the annotation scan extension can basically load it as from WAR file, because we know WAR file is only like closed world, so you have all the classes, all the resources there, and it's possible to scan all of them. But in this case, I have flat class path, so very general, very simplistic. So my extension just provides the pointers to the classes. It's also when you have Spring Boot, you also need to provide the package name or the classes that you want Spring Boot to scan and discover annotations on, if you have flat class path. And then we continue with the same thing that we had before. Now we have a REST resource. using Jersey, Jakarta REST, and it does basically the same again. It just returns some text. In this case, it gets some input from body, and it prints the name of the person. And in this case, I hope I have a script to measure again. Yes, here, this is where I made a mistake yesterday, that I copied the class name to a different file. It should be Piranha REST app, and the package is Piranha REST. So maybe this is also interesting how I start the application. It's just plain Java with class path, with all the dependencies I have in the Maven project, which there are not so many, and then the class. And when I now start this, yeah, I have to admit that we no longer get to the same numbers. We get close to 1 second. So REST is not that optimized. I think I'll have to edit here as or I'll just rewrite this. So now the first one here is the plain servlet. When we get REST, now it's almost 3 times, or even more than 3 times long to start, but it's still under 1 second. And it will eventually get faster as the framework develops and the integration with Jersey is improved. This is an example of Jersey unoptimized, so you can reuse anything that is out there, any servlet, but you don't get the amazing startup time, but you get pretty good startup time, comparable with other frameworks. I think when I tried Quarkus yesterday, it started around 600, 700 milliseconds with similar stack. So yeah, it's a bit faster, but it's comparable. So with any other framework out there, I assume that it's harder to get under 500 milliseconds, half a second, with a reasonable stack that supports REST services. I think that's it. I could show you how it behaves in AWS Lambda, but maybe I will just quickly show you to get an idea of the code and why Piranha is nice to use with Lambda. No, not this way. This thing, Piranha function app. So the basic thing in AWS Lambda or functions in the cloud is that you don't have the HTTP stack because it's provided by some other service. It generates an event, and the cloud provider basically just calls your method, the Java method itself, with some objects. Which is basically the same that we did with Piranha. We also created a Piranha container and then called the service method and provided the request if we did this thing with HTTP stack. So actually, this is how Piranha fits well there. We just need to transfer this event into the embedded request that Piranha understands. Then we can configure Piranha with anything we want, and then we just call the service method. And then we have to map again the response to the response that the cloud understands. But it's a simple wrapper around Piranha. No additional things. You don't need the HTTP stack. Nothing that you really don't need is there. You can strip down the dependencies. And what I didn't yet tell you is it's not only in Java. The HTTP stack is a separate Maven dependency, so you can remove it completely from your application and add it as a dependency only if the code needs it. So that's important, otherwise it would have to be packaged with the application even if the application doesn't need it. So it's modular on this level, not only in code, but on separate artifacts, separate libraries, so you can really choose what you want. That's the idea about getting or removing all what's not important. Only choose what you need. Yeah, so that's it. If you have any more questions, I'll be happy to tell you. I have a few T-shirts if you like some T-shirts like I have on me, and that's it for my talk. Thank you.